We're getting ready to begin a study into similarity. And similarity uses ratios and proportions a lot. So, this first section, we need to just talk about, well, what do we mean by ratio? What do we mean by proportion? And I want to illustrate it here by this little rectangle that I have right here. I've got a rectangle that is 2 units wide and 3 units long. Now, one of the things we could say about that is we could say the ratio of length to width, written this way. And that just means L over W. Okay, this is the little symbol, or this is the little notation we use for ratio, is 3 over 2. So the ratio of length to width is 3 over 2. Now, that's a ratio. Now let's see what happens. So we're saying no matter what happens in this rectangle, we want to maintain that ratio, 3 to 2. So in other words, knowing that's the ratio, if someone tells us, okay, this is the ratio of length to width, then here's what happens. Let's suppose we increase the size of the rectangle. Let's suppose that we double each side. Well, now the ratio of length to width is 6 to 4. But notice, that's just 3 over 2. In other words, it reduces to that. What happens is we just multiplied both sides by 2. That's what happened. Now, let's see how we could use this. Let's suppose that we know the ratio of length to width is 3 over 2. And let's suppose that we have a perimeter of 100, let's suppose. And we want to find out, okay, if we have a perimeter of 100 and the ratio of length to width is 3 to 2, well, what is the length and width? How would we find that? Well, think about this. Look at this little rectangle I drew here. And notice I just put 3 and 2 for the length and width, but I put a K with them. Because what's going to happen is I'm going to multiply by something. I don't know what, but I want to maintain that ratio. See, if you put 3K over 2K, it's just 3 over 2 because the K's cancel. So I want to figure out what K needs to be if the perimeter is 100. So here's what I can do. I can go ahead and work this out. I've got 2K plus 2K. In other words, I add this side and this side plus 3K, this side plus this side. Yeah, and I know that has to equal 100. So if I do that, look what I get. I get 10K equals 100, and that means that K equals 10. So here's what we've got. The length is 30, and the width is 20. Now let's see if that works out. We got 3, 6, there's 60, plus 40, 20 and 20, and this makes 40. Yeah, so that makes 100. So that's how we can use the knowledge of what the ratio is to figure things out. Now, another place you see some ratios is in triangles. Here we've got a 3, 4, 5 right triangle. Now, so look, here's what we mean. 3 squared plus 4 squared equals 5 squared. Notice this is 9 plus 16, and that is 25 equals 5 squared. Yeah. So see, this is called a 3, 4, 5 right triangle. And it's the way that you can make real quick calculations. Because this, in a right triangle, this holds. It has to be a right triangle, though, to have 3, 4, 5 like this. It has to be a right triangle. So if you do have those proportions, you know you're dealing with a right triangle. But that's beside the point right now. Notice that we've got a ratio. So let me just do this. Let me say that this over here is side A, this is B, and this is C. Or actually, let me go the other way. Usually they put the C right here. So let's do this. So look, we could say this: the ratio of AB to AC is 5:4. Okay. Now, I want to come up with a triangle that maintains that. So look, here's what I'm going to do. I'm going to put a K here, a K here, and a K here. And let's suppose that K is equal to 2. Okay, if K is equal to 2, look what we've got. We don't have 4 here, we have 8. So dig this. We've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then instead of 3, we've got 6. 1, 2, 3, 4, 5, 6. And then we've got this up here. So notice now we've got 8, 6, and 10. So there's another triple, right? So you can see that the ratio, now we've got still A and B and C, but notice the ratio of AB to AC is 10 over 8, which is, if you divide out the 2, that's 5/4. So you see it maintains the ratio there. Anyway, this is an example of how ratios are used. Let's look at another one here. Here we have 3. We have 1. Let's suppose the angles of this triangle are like this: 1 to 2 to 3. In other words, notice this. The measure of angle B to measure of angle A is 3. In other words, B, the measure of angle B is 3 times the measure of angle A. The measure of angle C to measure of angle A is 2 to 1. That means angle C is 2. It's twice as big as angle 1. Well, if you have a triangle like that, what are the angles? We know that B is twice A, or 3 times A, and C is twice A. So how would we do that? Well, one of the things we can do is we can say, okay, let's let A be X, B be 3X, and C be 2X. Now we know that if we add up all of these angles, we have to get 180. So let's see what this is going to be. This is going to be 5. This is going to be 6x equals 180. So dividing by 6, you get this. You get x equals, what is it going to be, 30 degrees? Yeah, looks like 30 degrees. So let's see if that works out. We've got x is 30 degrees. 3x, that's 90 degrees. And 2x is 60 degrees. Okay, so let's see what that looks like. So this is 9, 10, 11, 12. That's 180. Yeah, that's it. Now, yeah, so there you have it. Now, that angle 90 degrees, this triangle obviously, it's not, doesn't have a 90-degree angle in it, but the way I set it up, it does. So, I mean, the way I drew it doesn't match the answer. So, but that's okay. That illustrates my point, or how you can use these ratios. Okay. Now let's move on to proportions. Proportions are what you get when you equate two ratios. So we've got A to B equals C to D. So, an example of that would be 2/3 is equal to 4/6. Yeah, of course. You multiply the top and the bottom of 2/3 by 2, and you get 4/6. Likewise, now notice nothing changes here if I do the reciprocal of both. Instead of 2/3, if I flip it and say 3/2, that's fine as long as I flip the other side. So notice it works the same. So we can flip these proportions. Now, by the way, these parts of these proportions have names. In particular, notice B and C, those are called the means. Okay, those are the means, B and C. And if you look at A and D, those are called the extremes. Just some terminology there for you. Okay, now I want to show you what we do with these. A lot of times we'll have this proportion set up and we'll have to solve for something. We'll have to do a little algebra. So we've got this proportion here. Look, 2 over x equals 4 over 6. And we need to figure out what x is. Well, you can just look at this and say, oh, x is 3. Yeah, because I had it right here, right? But not always is it that easy to tell. So we want to see, well, how would you solve a proportion like that? How would I find out what x is? Well, notice this is an equation. What we could do is multiply both sides by x. And if I do that, notice that x will just divide out over here. And what we're left with is 2 equals 4x over 6. Okay. Now I could multiply by 6 on both sides. And then I get 12 equals, the 6's cancel over here, equals 4x. Now, the last step is to divide by 4. But let me show you something. If we have 2 over x equals 4 over 6, notice what we could do. We could do we could do a shortcut here and cross multiply. In other words, I could take these numbers and multiply them together and get 12. And then these numbers multiply them together and get 4x. And dig this, I'm right at the same place I was. And that means, if we work through this, x equals 3. So we solve that proportion. Now that's going to be something that we can use a lot, that shortcut. So dig, if you will, this next one. I'm going to solve this that way. I'm going to cross multiply, and I get 3y equals 2 times y plus 2. There. So I did a cross multiplying. In other words, I cleared the denominators. I just did a shortcut there. Okay, so here's what we got. We got 3y equals 2y plus 4. That means that y equals 4. Yeah, that's it. So there's how we can solve proportions. Ratios and proportions are something that we're going to use extensively in this discussion of similarity.